In this assessment, we're showing what reagents and conditions we might use to synthesize the molecule on the right, starting with the molecule on the left. I've gone ahead and numbered the carbons to help us with this problem, and arbitrarily calling these 1, 2, and 3 shows us that we're going to need to make a new C3-C4 bond. Using the terminal alkyne, we're going to do this by first deprotonating it using sodium amide, or NaNH2. If we do that, we're going to make this carbanion, which we can now apply our numbers to with 1, 2, and 3. At this point, we know that carbon 3 needs to attack something to form the 3-4 bond. Well, we know that's probably going to be carbon 4. It needs to attack carbon 4. Carbon 4 has attached to it carbon 5, carbon 6, and the 3-membered ring that is on carbon 6, or that carbon 6 is a part of. Now, we're not quite through yet, because as the lone pair of electrons is donated to the carbon of carbon 4, something needs to leave. We typically use a halogen for that. So if we put a bromide there, we can imagine a mechanism where the reaction happens like that, and that would give us this product, with this lone pair being the 2 electrons that are in the new C3-C4 bond. So to clarify the answer to this question, we're going to add a base, make the terminal acetylide anion. That anion will displace the bromide to give us this product.